Good morning, everyone, and welcome to our session on forecast evaluation and accuracy. Today, we'll dive into a comprehensive guide that covers the essential methods, error metrics, and the limitations we need to keep in mind to make informed, effective decisions. I'm excited to explore these key concepts with you and help enhance your understanding of how to assess and improve forecasting models. Let's get started. Forecast evaluation is all about measuring how accurate our predictions are, which is crucial for making informed decisions. The main goal here is to understand just how reliable and effective the different forecasting methods we use really are. By looking at forecasts systematically, organizations can see how closely their predictions align with what actually happens. This kind of evaluation is incredibly valuable because it helps improve forecasting models over time and supports smarter, more confident business strategies. Evaluating forecast accuracy is crucial for several reasons. First, it allows us to compare different forecasting methods and choose the ones that perform best. This ensures we're using the most reliable tools available. Second, by measuring accuracy, we get valuable feedback that helps us continuously improve both our forecasting models and the overall process. Third, it plays a key role in risk management. By identifying the size and type of forecast errors, we can develop strategies to reduce potential negative impacts. Finally, having a clear understanding of forecast accuracy strengthens our decision making and helps us allocate resources more effectively, leading to better outcomes overall. Now, let's talk about some common plain forecasts that serve as useful benchmarks. First, the naive forecast is probably the simplest approach. It just assumes that the next value will be the same as the most recently observed value. While straightforward, it can be surprisingly effective for very stable data. Next, the simple average method takes a broader view by using the average of all past data points to make a prediction. This smooths out fluctuations but might lag behind sudden changes. Lastly, the seasonal naive forecast recognizes patterns by using the value from the same season in the previous cycle, which is particularly helpful in data with clear seasonal trends. These benchmarks help us gauge how much more complex models improve on basic assumptions. Now, let's talk about how we evaluate forecasts using different error measures. First, we have the mean absolute error, or MA. This metric calculates the average of the absolute differences between the predicted and actual values, giving us a clear idea of the average size of the errors without considering their direction. Next is the mean squared error, or MSE. Unlike ME, MSE squares the differences before averaging, which means it puts more weight on larger errors. This makes it especially useful when big mistakes are particularly costly or important to identify. Lastly, there's a mean absolute percentage error, or MAPE. This measure expresses the error as a percentage, making it easier to compare errors across different scales or units. It tells us, on average, how far off our forecasts are relative to the actual values, which is very helpful for understanding performance in relative terms. Each of these metrics gives us unique insights into the accuracy of our forecasts. When we talk about interpreting forecast evaluation results, the first thing to keep in mind is that lower error values are a good sign. They mean our forecasts are more accurate and our predictive models are performing well. But it's not just about the numbers. These results serve a practical purpose. We use them to fine-tune our forecasting models, making adjustments that lead to better predictions down the line. At the same time, context is crucial. Not all errors carry the same weight. Some might have a bigger impact on the business than others. So understanding the specific situation helps prioritize what improvements matter most. Ultimately, by thoroughly understanding these evaluation results, we can make smarter, more targeted decisions that drive meaningful improvements in forecasting accuracy. When we rely solely on plain forecast evaluation, we risk missing some important aspects. For instance, it can overlook complex data patterns like trends or seasonality, which are key to understanding the full picture and capturing subtle signals in the data. Another issue is its sensitivity to outliers. Even a few extreme values can skew error measures, leading to a distorted view of how well the forecast is performing. Additionally, plain evaluation methods aren't suitable for every type of data or forecasting situation. Using them blindly can result in incorrect or misleading conclusions. That's why it's crucial to be aware of these limitations. Understanding them helps us apply forecast evaluations more effectively and interpret the results with the right perspective.